Oh, okay, let's see. And how do I do that? Mm-hmm. Then desktop. Now, how do I minimize this darn thing? I'm telling you, that's for sure. This won't go away either, so I don't know what I'm going to do. Let's see. So first thing I want to say is thanks everybody for coming. You know, I know you have a lot to do, and so I appreciate that you carved out some time to spend it here with me today. You know, some of us have mortgages to pay, so all right, we're going to work this out. All right. Can you see this now? Woohoo! Yay! So, for those of you who don't know me, my name is Kevin Kline. I've been in the IT business since the late 80s. 86 was when I first had my first big technology job. And I worked for NASA down in Huntsville on the International Space Station. At that time, relational databases were really new, and I was a really good Fortran programmer who also knew SQL. So it was like, boom, NASA wants you. Anyone love and work on Fortran these days? All right, Dave and I, we're the representing for my peeps. Yeah, that's right. Global, anyone? There's some folks in here with gray hair. I know somebody's used Fox Pro. Come on, Clipper. All right, all right. So we're going to toss out some T-shirts too. One of the things that we decided to do this summer was summer is kind of a traditional slower time of year, not as much going on. Everybody's taking a little time off, and we thought we'd spin that on its head and create a little social media campaign around this. One thing that's great about the SQL Server world, which I'm a big supporter of, I was one of the founders of PASS. I was president for 4 years of the organization, and so I'm hugely supportive of the grassroots effort for us to come together as a community. And so you may not realize this, but PASS is really, really active. The SQL Server world is really, really active, much more so than, say, the Oracle or the DB2 world, any of the other relational databases on Twitter and Facebook and things like that, than any of those other ones. If you're not using Twitter, I understand. It was out for a couple years, and I didn't think it was worth anything until I found out the value of hashtags. Anyone heard of hashtags? Jimmy Fallon's always saying, hashtag I'm too cute or whatever it is, Let me make sure you guys have seen this because it's pretty awesome if you haven't. Let's see here. So I've already written a blog post about you guys. You saw Dave's picture there. And the idea for this particular trip is we're kind of doing a riff on the old National Lampoon vacation films with Clark Griswold, and they got the Wally wagon and they're going all over America. Well, I have 7 kids, and so anytime I take a vacation, it's never a vacation. And so I thought, well, heck, I'll just bring them with me and we'll speak and go to some of these user group meetings. So here's a little bit about you guys and about Dave. And the other thing I wanted to show you, though, is, and this is strange how it's not actually letting me see the top. How can I make that go away? There we go. So Twitter's not useful if you just use Twitter. Twitter becomes useful when you use one of the tools like TweetDeck or Hootsuite. And then what you can do, here's everybody that this is looking for one diamond, and that, that's not really useful. What's useful are these hashtags, where you can come in here and you can type in something like "Ask." This is the one I recommend for new people who've never used Twitter before. Some of the best minds in the SQL Server business keep an eye on the hashtag for SQL help. And you could throw a question out there. You might be the only smart database person in your company. That's something I find really often. You know, you've got a lot of .NET people around, but none of those men or women know a lot about SQL, for example. So you can ask questions here and get fantastic responses, typically very, very quickly, right? So this hashtag is kind of like a creating your own TV channel of just stuff you're interested in. So if you were really interested in horse racing or, you know, one of the sports teams or something like that, you could just zero in on that with your hashtags and keep an eye on that sort of stuff. So that's where it becomes super powerful, and that's where our community is connected. If you decide to get involved, or if you already are on Twitter, we have a contest going on. So when I pass the sheet around here today, we're going to have several giveaways that we'll announce after the fact. We'll contact you by email. We're going to give away some licenses to one of our very popular products called Plan Explorer, the Pro Edition. That's $300. We're going to give away some embroidered courier bags and things like that. But if you go online, and also anytime you tweet about or put on Facebook or LinkedIn even, any of those kind of things about SQL vacation, like you go to the beach or you go up to the Great Lakes or you go skiing and you put this on there, through the end of July, 1 out of 25 people will be chosen as winners too. So just an idea to get the community sharing and people active and just being expressive. And it's really neat too. Dave could probably talk to you at quite a length about this. When you finally get the chance to go to the past summit, what you'll find is people all over the place who are like greeting each other like old friends, even though they've never met before in real world, right? Because they've gotten to know each other through the virtual communities that we have, things like Twitter. It's like, I'm so glad you actually put a picture of your face on there because I can recognize you, SQL Ninja 97, you know, or whatever it is, you know. So it's kind of neat. It's like a big family reunion in a lot of ways. All right. So a little preamble there. Also, I have some information about my company, SQL Century. I do a little bit of consulting on the side for team leadership and management, things like, you know, converting to Agile if you want to. I have some flyers for that. I have some stickers up here as well. We've got a limited number of T-shirts we'll be giving away. And please do feel free to ask questions as we go along if there's anything you're wondering about. How many of us here are primarily development-oriented in our daily work? About a third of us. How many of us are primarily database administration? Third or less, maybe a quarter. A lot of you didn't raise your hands. You're like, I don't know why I'm here except for the pizza. How many of us are generalists? No? Okay. BI? All right. A lot of you didn't raise your hands. How many of us are managers? You don't do anything. Okay. All right. What did I miss? Some of you. Oh, there you go. There you go. And you make sure your people get paid. Yep. Cover models? Yes. Okay. I'm a cover model. What else did I miss? Any SAN admins in here? People we can talk bad about? No one can bet. Well, not everybody. Some of you are just quiet. Okay. Well, this session has a lot of good content for both DBAs and developers. I believe if you're doing anything that involves writing SQL code, this should be useful and good information for you. Another thing I'd like to mention, this is as much as the commercial announcement you'll get from my company. SQL Century, we're known as the premier tools provider in the SQL Server space, the best, the highest quality, the most informative, the lowest overhead for monitoring and tuning products. We have a performance tuning website called SQLperformance.com, extremely popular. We're all DBAs like you guys. We're all developers like you guys. And we know the last thing in the world you want is an unsolicited phone call from a salesperson. So we never do that. And we hardly ever send emails for that matter. So maybe that's why we're not making as much money as we want. I'm going to make 20 million, right? So, yeah, we're not a hard sell kind of people. We're here to help you solve problems. And this website, there's another one called answers.sqlperformance.com where we give you free consulting help on really hard to tune queries for free. We also put out a ebook every year. These are not throwaway 40-page things. These are $10 each on the Kindle bookstore. We'll give them to you for free. They're usually close to 400 pages in length. So just send us an email at ebooks@sqlcentury.com. We'll get you as many as you want for free. You won't have to pay for those. All right. What are we going to talk about today? So these are 10 techniques that will make the DBAs in your department happy if you do a lot of development. If you're a DBA and you're not doing these things, you might make yourself happier, which is kind of a surprising thing. But a lot of these lessons taught today are ones that I learned the hard way, right? I didn't know how to do them when I started. When I was starting out as a database administrator for SQL Server, the only models we had to follow were big, really big mainframe size database environments. So the previous Oracle system I had worked on was running on a CDC mainframe. The mainframe cost $2 million, right? And the yearly maintenance on it was $200,000 for one instance of Oracle, right? So some of the lessons that I learned being, responsible for that kind of environment are different in the SQL Server world, typically because we have lots of SQL servers we have to look after, not just one. Anyone here manage one SQL server? You laugh, right? It's like, yes, right, yeah. Go on with you. Yeah, SQL servers tend to be, quite a few of those in our enterprises. So that's not the case in some of those other big environments. Now, one of the things too it's kind of funny. Dave, I think, has stepped out. Mattingly has stepped out. He actually told me a joke that goes to the heart of what this slide says. When DBAs and developers get together, there is this fundamental disconnect. The joke he said was, what did the DBA say to the developer? Nothing, because the developer wasn't listening, right? And what did the developer say to the DBA? Well, nothing, because the answer is still no, right? And he just told me that, and this I wrote a year ago, and this is exactly what we see in this environment. So I was a developer for 6 years before I was a DBA, and I loved to build stuff and get it in production. That was what I loved to do. It was disappointing and annoying when I would be thwarted, that something I was going to roll out into production didn't pass some unspoken test or a test that I didn't know of, or some kind of quality check that nobody told me about. It was usually the DBA who thwarted me, right? And even worse than not getting to deploy something was if I had rolled something out and then was told later I had to take it back out of production. That was like going in and taking my Lego set and just smashing it, right? No. It took me so long to build it, right? On the other hand, as a developer, I was thinking these DBAs are, they're just so stodgy, so conservative. They always say no. The flip side, the revelation came for me when I was a DBA, at the time I experienced the first substantial meltdown of one of our systems. It was this was in the early mid-90s, 96, something like that. And it was, a Windows system, but it was a couple $100,000 worth of hardware. And when this thing melted down, smoking pile of slag, I expected a call from our C-level people, the CIO, but he didn't ask what I thought he would. I thought he was going to say, what happened to my incredibly expensive computer? What are you going to do about my computer? He didn't ask that at all. He said, what are you going to do about my data? How long before I get my data back up? It was at that point I had an epiphany, because as a developer, all those years working on these huge mainframes and then these smaller distributed departmental servers, I was still thinking about the computer system as the asset of the company, when in fact that's a mirage. What's really valuable, what is the asset worth protecting in the company, is the data, okay? And I would write code sometimes that screwed up data, right, as a developer. I wasn't getting it. It was at that point that I realized I'd had the entirely wrong mindset. And so when I started to work with my developers and say, hey, what you think might be the most important thing isn't, right? You got to make sure your totals are right. That's why we don't use no lock. Some of you are like, I love no-log. So yeah, I understand. But you're gonna get spurious results sometimes, right? So those kind of things started to make sense to me. And it was also at that time that I learned that I need to teach people why I ask for certain things. As the person they see as the roadblock, maybe I can be more of an educator, make sure I'm a facilitator of movement into production rather than an inhibitor. So here's something that is a really important problem that we face when we're building big systems. We want them to be really fast, we want them to be effective, and yet the way we construct our development processes and the way we do development keep us from being really good at building high-end database systems. So here's the big example that I like to use. First time I ever had to work with a multi-terabyte database. You know, this is back when hard disks were typically measured in hundreds of megabytes, you know? So you know what kind of cost I'm talking about. Really expensive to have a multi-terabyte database. And one of the things that we always struggled with was getting a copy to the development team that was even kind of realistic. And in fact, it's something I see people struggle with a lot today. We've got our development efforts are going on individual workstations, but they're going to be deployed on big servers in production. So something I was talking with a person on email just recently about is they got a server with 128 CPUs, half a terabyte of RAM, massive back-end storage subsystem. Everybody on the dev team has 4 CPU workstations with like 4 gig of RAM. So when you write a query here that you think is picture perfect for that production environment, how sure are you of it? You're not until you see it in production, right? So what we need to be able to do is create a version of that production database on our workstation and yet not actually need 2 terabytes of disk space because we don't have that. So I'm going to show you some tricks to do that. All right, so let's go over to Management Studio. The first thing you have to do is you have to build a database clone, okay? Now, I've talked to devs, and sometimes they'll go out and they'll like take a backup and restore it. It's like, now it's 2 terabytes. What am I going to do? And so they take all kinds of data out and throw it away, or sometimes they'll use the export wizard and move some tables over. Don't do that. Create a database at the size you want it to be. Let's say you create a database at 4 gigabytes instead of 2,000 gigabytes, 2 terabytes. And then you create a script of that database. So in the case of AdventureWorks, you probably have seen this script database as, and that is a red herring. That is a false trail. Do not use that. What you want to do instead is go to tasks and use generate scripts, okay? We go over to the generate scripts. You could say entire database or just the specific objects if you like. The secret ingredient in this recipe is under the advanced button. So what we're going to do is we're going to come down here. We're going to say create script statistics. Now, when you have a database, one of the major things that determines the execution plans that SQL Server will choose are the indexes upon which those queries process, right? And then another step further than that are the statistics of the histogram underlying that index. You have to get both to get the full picture. And so you can come here and you can say script statistics and script histogram. So we say yes, and then we let it process. Take just a moment or two for it to build. Now, another thing that's important is when you build out the database, when you create that little database file, you do not leave it at the default. You go in and turn off auto update statistics because we want it to think it's a 2 terabyte database in production when in fact we're going to have a 4 gigabyte version or a 2 gigabyte version here on our desktop. So the way we do that is, just like if we pulled up Google Maps, you have all the streets and stuff, and you know how it doesn't actually show a picture of the building? That's kind of the stuff we're doing. It's just this little gray spot, but it will take you exactly where you want to go. thing when we have indexes that have the exact same histogram, the exact same statistics, even if they don't have the exact same data underneath. Okay? So let's open that report. And if you look at that script, you'll see down in there update, alter table statements that have all kinds of weird things. Let me see if I can pull one of those open for you for that matter, just so you can take a quick look at it. Oh, wrong one. So, oh, that's not what I want. I've got it somewhere else. Temp. I've got a copy of it somewhere. Anyway, oh, here it is. So let's go way far down here, and we'll start to see, those are the histograms right there. See that stuff? Update statistics, create statistics, update statistics, and so forth. This is kind of the hexadecimal machine code to actually, there's no data behind it yet. We've turned off auto update statistics. That's because when we load in data, we don't want it to overwrite those statistics that it already has. Now, the next step after that, there's a little quick and dirty script that I've written here. And what this does is this uses BCP, and I've told it to take the first 100 through the 500th record of every table and put it out to a CSV file. And then you can turn it around and import it back into it. So now we only have, and you could tinker with this if you wanted to. You could make it 1,000 records or 4,000 records or something that works inside your environment. But now you've got a database that is functionally, in terms of what the query engine inside of SQL Server will do, identical to what's in production. Okay? Not the same. It's functionally equivalent, though. And as long as you don't update those statistics, it will give you the same execution plans. Now, if you've got a lot of experience, you're probably going to say, well, that's not everything that causes SQL Server to choose the kind of execution plans it chooses, to act the way it's going to act on your development workstation. And that is true. Let me show you another important, let me see here. Where's my what if? I don't know why I didn't open that one. So, here's another really cool trick that nobody will tell you about. If I, let's execute a command as it stands right now. We're going to turn on the graphic execution plan viewer, and I'm just going to execute this kind of simple join on the AdventureWorks database between the sales order header and sales order detail table. So when we execute it, you can see it's taken a few seconds to process. And look at the shape of this execution plan. As we move over here to the right-hand side, we see it does a clustered index scan, it does a seek. All right. In this case, I want to make sure every time I execute it, it produces a new execution plan. All right. That's because I'm gonna muck around with it here, right? There are certainly times when you will want to use that, but in this case, I'm using it just for the example of this demo. Now, SQL Server will choose different kinds of execution plans according to how much memory it has, according to how many CPUs it has. If it has a lot of CPUs, it's going to be much more inclined to parallelize a query than if it doesn't, right? So we can tell it that this server really has those things and behave like it has those things when it doesn't. So I've got this 4 CPU box here. I'm going to tell it to act like it has 64 CPUs. Right here, DBCC optimizer what if CPUs is 64. Okay? Now, let's see what we get here. We're going to execute this again. It's going to create a new execution plan. That's what the recompile says. Now let's see what the shape of that execution plan looks like. What's the form of the plan? Oh, wait, what's this? In fact, this little circle right here, that means that step has been parallelized. This step is, that symbol wasn't there on any of those steps before. Well, hell yeah, we got 64 CPUs. Let's parallelize the crap out of this, right? So that is the way it would behave in production, which a developer would never see on their little dev workstation. We can do, same sort of things. We can say, hey, we got a terabyte in production. We want to act like you've got a terabyte in production. So again, I'm not sure if the execution plan will look a lot different now. That didn't seem good. All right. All right. Yeah, I'm sweating now. What was that? I think that's essentially the same execution plan, to be honest with you. But now here's something interesting. We can go the other direction too. We could say, act like you got less resources than you really do. Why? Well, a lot of people, when they get a 128 CPU server, they put 64 VMs on it, right? And my little workstation here has 4 CPUs and 4 gigabytes of RAM. But many of our VMs are going to be standard edition with 2 gigabytes of RAM and 2 CPUs. So we can go in the other direction as well. We can say, I want you to act like you've got less than what you really have. So my dev box has a lot more than that. I'm going to tell it, act like you've only got 1 CPU. Come back and execute that now. See what this looks like. Remember it did a nested loop join before? You can't use that particular operation with only 1 CPU. So it has to do a lot of its work now in TimDB because it's got to create a work table because it didn't have 2 CPUs to handle the 2 different intermediate result sets. And none of these have that little circle indicating a step has been parallelized because I don't think I can. I've only got 1 CPU. Can't parallelize anything. And then finally, of course, you should really come back at some point and set, set things back to where they were. Now, this is only in play for the duration of this session. So if worst came to worst and I logged out, the session is disconnected and goes back to normal. Any of us heard of using this before, this technique before? Okay, one of us. All right, so I failed you. Everyone else, I taught at least one thing today. All right. You have to do it using the scripts that I showed you. Yeah, I just showed you how to do that. Yeah. Sure. Yeah, you can use the alter table statements if you want to do that. Yeah. Mm-hmm. Yes. No, just your session. That's right. If I execute it, no, it's gonna be a single-threaded select statement because that's what it's sent back. So it will perform that execution that way as a single-threaded statement, but that it did have other options. So yeah. Do I approve of that? No. Do not approve of that. Concurrency. There are ways, and you have to use tools typically to do that. There are a few free tools, but the ones that are good, you have to buy. The one I like the best is Dell Software. I used to work at Dell, full disclosure. Dell Software's Benchmark Factory. But you can also use Profiler to do that. You can record a workload with Profiler and then use the built-in feature that shipped with SQL Server 2012, I think. Maybe it was R2, called the Distributed Replay Utility. And you can replay 20 copies of your Profiler trace and, just let it run. So yes, you can simulate that. It's not easy, and I have a session you might want to download off of my website called Performance Baselining and Benchmarking. So that's a difficult thing to do, but it's very worthwhile if you have the time and energy to do it. Okay. Yeah, good question. Yeah. Did not. Right. Yeah. We only got number one done. So 3 o'clock, okay? Did I get stuff done? All right, let's move a little quicker. Right. All right. So I'll try to hurry up a little bit, and I'm not going to answer any more questions. Does that feel good? All right. Thank you, Dave. Killjoy. All right. So one of the things, way back in the day when I first started working on SQL Server, I was given a really big stored procedure to rewrite and make it perform really well. And I printed it out. I remember it was like 16 pages long. It was like 3K. That's how big the file was, 3K. I was like, wow, this is a huge piece of code. And I went in and applied a bunch of kind of best practices to the code, and then I executed it to see how long it took the first time, and then I made all those changes to see how long it took the second time, and it was way fast, much faster. It's like, I am a transact SQL to be God. This is great. And older gentleman, gray-headed guy, became my mentor later on. He's like, what did you do about the caches? How'd you handle that? And I said, what are these caches you speak of? What I didn't realize was that the first time I ran the query, it got all the data that was affected by this particular set of functionality, loaded it up into the data cache and the plan cache, did its work, finished. And then the second time I ran it, everything was already in the cache. So it didn't have to inquire from the disk subsystem to get that data that it needed and loaded it up. And so it was twice as fast because I was an idiot about the cache. So again, one of the things I learned is you have to have test harnesses, okay? The test harness ensures that everything is identical in your two environments. So in my case, back in those very, very early days, we could not clear caches except by restarting SQL Server. Not a good idea if other people were on there working and stuff, right? But that's called, restarting is, that's called a cold cache test. And it's the more desirable kind of test to do because it represents what the worst case scenario might be for your end users. If none of that data they need is resident in RAM, it has to go out to the disk or whatever your subsystem is and pull it up into the cache. So that's the better way to do it. What we had to do back in those days is called warm cache testing, where we would run whatever the code was, and we'd only measure it on the second time we ran it. First time was to get all the data up there. Second time was to measure it, because that was the only way we could ensure that we got apples to apples every time we did a comparison. If we took the measurement after the first run, we wouldn't be sure that it was a warm cache or not. So they couldn't be guaranteed to be equal. So one of the things I do, I use start and end times occasionally if I'm testing something like multiple stored procedures all in one batch. But usually what I do is first I issue a checkpoint statement. This flushes all dirty pages, all pages that have changed in the data cache but have not yet been flushed to disk. Because whenever SQL Server does a checkpoint naturally, it causes a great big spike in I/O because it's pushing all those dirty pages out to the disk. So I do it myself manually to make sure it doesn't happen in the middle of my test. Then I clear the caches with these two statements. And there are some variations of these statements that you can use. DBCC drop clean buffers clears out the data cache, empties out of all the different tables and indexes and such that have been loaded. And then DBCC free proc cache clears out the plan cache, all the ad hoc and prepared SQL statements. And so that's very useful. There are actually another dozen or so very, very small caches that usually aren't important for performance tuning and writing SQL code. You can clear those out as well by saying free system cache. I don't usually feel like I need to do that, but you might want to if you have a stored procedure that's hitting some of those other caches. An example of that would be if you are if you're using extended events. Each extended event queue that you create has its own cache. So then I prefer to use, just because I've been doing this since before SQL Server was a Windows product, it was an OS2 product before that in the early 90s. It was a Sybase product as well on Unix. I like to use the set commands. You can also do these through the GUI by going to query, menu, then the query options setting, and you can come over here to advanced, and you can turn on some of these exact same things. But I like to set the statistics on and the time on. I'm sorry, statistics IO and the statistics time on. Then when I execute a query, I know that the cache is clear, and if I look in the messages component here, I'll see the amount of time it took to process this query, and then all of the different tables, all the different IO that it did. All right? Now, it is possible that your CPU time will exceed your elapsed time. Elapsed time is the amount of time that transpires on the clock. Right? How would that happen? That the CPU time is, let's say, twice as high as the elapsed time. Parallelism, right? Multiple CPUs doing that work. Yeah. So this is telling me in 8K data pages the number of reads that happen from RAM. If we see physical reads, that's a less desirable sort of thing. If we see scans, that's probably not good. Not necessarily, not always, but possibly. Okay. And so that gives me an idea of what the overall IO workload is for the SQL statement. And truth be told, usually it's IO that's causing the problems. That's the most typical place SQL Server will have issues. That's not to say it won't have issues in other parts of the stack, but that's the most common. And so when I'm testing all these things out, I want to make sure that my environment is stable and repeatable, and so I use a test harness every time. All right? Okay. That's the number 2 tip. We might make it through 10. I don't know. We'll be close. All right. How many of us actually know how to read execution plans? You don't have to raise your hand. I know you're self-conscious. Some of you like, really? This is really, really important. It's really worth your time to learn how to read execution plans. They are, I don't like the way a SQL Server does it naturally, I got to be honest. Let's see here. I'm just going to execute this particular query, and I'm going to get an execution plan for this one here. So execution plans, you read from the right to the left. And this is the lowest level statement here. If you hover over that particular step of the to the left of it is doing a join. So these are all the different steps that it's doing as it moves through the different work. You know, SQL Server is a declarative, SQL is a declarative language. You tell it what you want, not how you want it. It goes out and decides for itself what it's going to do. And then it merges in these additional steps here to bring in, you know, other parts of this join, this result set, and there's actually quite a few different joins going on here. Now, the thing to look for are the red flags. When I was first learning, I thought, man, oh man, I'm never going to learn this. So what you want to learn are a few of the red flags. So you want to look through that graphic execution plan, or the XML, or maybe you want to see it textually, so there are a couple commands you can, they're set, show plan text on, and you want to look for lookups, an operator that's a lookup, depending on the version of SQL Server you're on, they could be bookmark lookups, or they could be key and row ID lookups. Scans, remember that had a clustered index scan? How many records of a table are in their clustered index? All of them. That's the physical sort order of the table. So if you have a clustered index scan on a table that has 2 billion records, how many records is SQL Server looking at? All 2 billion of them, right? Spools are a big deal. So you will see from time to time an eager spool or a lazy spool happening. That means part of the result set or part of the intermediate steps in a particular execution plan are being resolved with a work table in TempDB. And nowadays I see more and more companies putting more and more databases into a single instance of SQL Server. And that's particularly dangerous because no matter how many databases you have on a SQL Server, there's only one TempDB. So I've seen people who don't really do a lot of tuning or aren't really aware of performance on SQL Server ignoring TempDB, saying, SQL Server will take care of it, and it will do the best it can, but computers are high-speed idiots, right? And they'll go as fast as they can doing the stupidest things in the world because that's what you told them to do, you know? So spools are one of those things to look out for. That's not to say that it could be avoided every time, but there are lots of times when you can just change programming a little bit and get rid of spools. And then parallelism. Now, just a quick aside, I don't like to use max degrees of parallelism equals 1. That's what people will tell you. That's what the internet says on quite a few blog posts. And we all know the internet is always right. Always right. Now, and I've seen different people tinker with different settings for max degrees of parallelism. I would encourage you to leave it at 0. And instead of max degrees of parallelism, I would encourage you to actually use cost threshold for parallelism. Okay? This is a different setting, and the default is 5. That means SQL Server will take a look at all of your queries. And when I say query, I mean that interchangeably. It could be an insert statement or an update or a delete or a select, any kind of transaction. And if it thinks it might take more than 5 seconds, that's the default, to process and return a result set, it will try to parallelize it. And that's a really aggressive rate of parallelism. I typically set it to 30. I have friends, Brent Ozar, for example, I think he sets it to 60 by default. So it's one of those things where SQL Server tries to parallelize everything. And I would encourage you to say, just parallelize the big stuff, right? It's the bigger ones. There are some other red flags that are outside of query operator steps. For example, I encourage you to always pull the estimated execution plan and the actual execution plan. They're 2 different buttons in Management Studio. Anyone know why that's a good piece of advice? Mm-hmm. Right. Yeah, that's right. And basically, from down what you just said, it tells you whether your indexes and the statistics of those indexes are up to date or not. Because it will look at the statistics and it will say, it says I got 1 record in there, when in fact it has 100,000 records that meet that result set criteria. So you can only see that in action by actually comparing the estimated plan, what it thinks it will do, compared to the actual plan of what it will actually do. There's also some alarms like the missing statistics alarm. And then another thing I'll show you called data type conversion, or implicit data type conversion. Yes? Mm-hmm. No. Nope. SQL Server will auto-manage that. Again, that's, let's say, in a production database where you have auto-update statistics on, okay, which I do encourage you to do. By the way, there's a trace flag that you may want to use, 2317. If you have a really big database, a lot of people don't realize that the update statistics threshold is fixed. SQL Server says the values in this index have to change 20% or more before I will update the statistics. Now, again, if you've got a really big table with 200 million records in there, that means 40 million records have to change before it's going to update those statistics. Wow. You know, some systems might take a month before that would trigger. So use that 2317, or is it 2713? And what that does is that tells it after 100,000 records, use a sliding scale that goes downward. The more records are in the table, the lower that threshold needs to be before I'll do an auto update statistics on that. And of course, you can also take a look at your statistics. And one of the things I would do is I would frequently run the update statistics command myself. So you can keep those fresh yourself. All right. Now, another thing I find is that particularly, well, I shouldn't say, I was going to say developers often don't know this, but I've run into many, many DBAs who don't know how the plan cache works. The plan cache, actually in the data cache too, it's just a more elaborate, sophisticated model, uses LRU. What's LRU? Thank you. He's recently used LRU-K. K stands for complexity. I don't know what K stands for, but that's semantically what they mean. Maybe it was a German who wrote it. I don't know. So here's how it works. Whenever you compile a piece of code, and you can SQL code, SQL Server creates two numbers for it in the metadata. One is the complexity counter, the countdown timer, and the other is the complexity value. So we've got all this stuff in the plan cache, and about every, well, you know, as processing time goes on, twice as big as the next largest one. It's more than twice as big as well, the complexity value for that. Now, about every minute, the lazy writer, in this case I'm using Sheldon Cooper, the lazy writer wakes up and takes a look around to see if any of these have been used or not. Remember, at least recently used. If they haven't been used, he goes through and decrements all that haven't been used, that complexity counter. About a minute goes by. Now, there's other things that can happen. There are thread requests that can make SQL Server update these values, but all things being equal, everything working under the defaults, every minute or so, that lazy writer will come back and take another look and sees what's happened to these different ad hoc queries, stored procedures, and things that are in the cache. And when one of these hits 0, what do you think SQL Server will do? Archive? Delete it? Well, you think it's going to clear out the, you know, make that space available in the cache, right? The correct answer to every technology question is, it depends. Thank you. Yes. So what it does is, I heard someone say the term, it ghosts it, and that is technically correct. So there's a bit that SQL Server can flip that says this has outlived its lifespan, its complexity lifespan. And so if there is memory, this is what it depends on. If there is memory pressure and it's gotten 0, we'll get rid of it immediately. But if there's no memory pressure, well, get rid of it. And, you know, somebody might ask for that at some point, and I can reuse it. So if there's no memory pressure, I'll just keep it. But if there is pressure, out it goes. And so you may have noticed in the SPIDs that are less than number 50, those are all system SPIDs, there's one called the ghost cleanup process. And that's what his or her job is. I don't know what its gender is yet, so. But as time goes on, someone will execute some of these. And so the next time Lazy Writer comes back, Lazy Writer will actually reestablish that complexity counter and keeps it in the cache. The idea is that compiling code is expensive and arduous, and so we want to make SQL Server more hesitant the more complex it is to get rid of it. While, on the other hand, the more difficult it is, or the more easy it is, we could throw that stuff all away very, very quickly and very easily. Because we can. What's the difference between the plan cache and the buffer cache in terms of how it handles that aging and so forth? I have two answers for that. At the 10,000 foot level, and then at the microscope level, looking at it like this. in the grand scheme of things, it's very much the same. It has aging algorithms, and it tries to keep the most difficult to acquire data in there the longest. The longer, really long, detailed story is that SQL Server has an elaborate set of heuristics that it applies. So it applies all kinds of conditionals. Is it a heap? Meaning, does it have a clustered index or not? Does it have multiple non-clustered indexes or not? Is it of a certain size or not? Because SQL Server always reads in 64K extents. It'll do a full table scan every time if your table's less than 64K, right? So, and it'll flush it out in the same way. So it asks all kinds of questions each time it looks at stuff. Is this an index? Is it a non-clustered index? Is it between 2 gigabytes and 4 gigabytes in size? Then use this as part of the algorithm. If not, then use this. Really interesting stuff. All right. Now, another thing that is related to this is how SQL Server compiles and loads things into the cache. And a lot of times I find developers, DBAs, don't know this as well. So what happens under normal circumstances is that SQL Server will, when you execute a query or execute some code, SQL Server will take a look and check to see if something very similar has already been used. Is it in memory or not? If it is, I can just reuse that. I just change a parameter, the name of the city that you want to fly to or what have you. If it's not in memory, then it has to come back and load all of the code into the metadata. It has to compile it and optimize it, and then it's able to execute it. However, there are times at which it tries to execute it, that something has changed so significantly, all the assumptions it made up to that point no longer stand. I have to go back and recompile the same code in order to make sure I've got my bearings. The most common reason for that, some of them make sense, like schema changes. I changed the table that's in use right now. I added a column to it. And so all the queries that are happening on that might need to change. So SQL Server invalidates those execution plans and makes the next person to execute one recompile or compile a new plan. The one that most people don't know about, though, is that anytime you have interleaved code of DML and DDL, those are two subsets of the SQL standard. The DML is insert, update, delete, select, or merge. Those are the DDL statements. And then DDL, the data dictionary language, is create, alter, and drop. I had one friend who called me over to his medical practice management software company. Said, we've got a real problem with our performance. We've got two kinds of customers. A small OBGYN practice of maybe as many as a dozen doctors in a partnership. No problems ever. And then we have two customers that are huge. They're like the Mayo Clinic. They got 120 doctors in partnership. And those don't work well at all. And so when I went and took a look, they had over 400 stored procedures that went like this. Create temporary table. Insert into the temporary table all of this data. Alter the temporary table, add a column. Update that temporary table to put values into that new column. 3 months later, they realized they needed another column. Alter, table, add a column. Update to do all this stuff. And so they had over 400 stored procedures, all based on temp tables, all interleaving create, alter, drop statements with insert, update, delete statements. And so what would happen is they would invoke the stored procedure, get this far, and say, oh, got to recompile, go up. Interleaves, oh, got to recompile, go down. And so their ratio of compiles to recompiles was like 18 to 1, right? One piece of code had to go through 18 recompile operations to finally complete. Some remedies you could think for this kind of approach to coding. Yeah, put all the DDL at the top, right? You can have, or just have one create table statement and get rid of all the alters that add extra columns to it. Same thing will happen with select into. Well, yeah, you just put it at the top right after the create statement. Then you have an alter statement right after. It's the interleaving that causes the problems. Another thing you could do with, yes. sure I understand. Okay. You could just drop it because the truncate is superfluous. It'll get rid of all the data as well. Uh, it will log. It will log a little bit more. Yeah. Truncate are logged. They only log the page allocations as opposed to the individual records. So it could save a little. No, that is a DDL statement. Create, alter, and drop are DDL statements. But if that's the last thing you're doing, you pretty much know it's not going to interleave again. So you're really pretty much okay in that specific scenario. There's a couple other things you could do. If you had subordinate stored procedures, let's say, so you created an object and then you called the stored procedure that did the insert, right? Each of those will have their own execution plans and won't get recompiled every time. You could also use table variables, which I don't recommend in many circumstances if they have a large number of records, but table variables do not cause this problem. And then you can do what we did, which was to refactor the code, which was to actually read the whole statement and say, why don't we just create one table at the top that has everything we need in it, and then all the other statements right after that, instead of that kind of piecemeal approach. In fact, we later realized that with about half of them, we could create permanent tables and put indexes on them. We made it all a lot faster, right? All right. How many of us write cursors? Okay. So we're like, I heard cursors are bad. Well, I don't say cursors are bad in every situation. I don't like to use cursors in production a lot of times because people don't realize there's a lot going on with cursors over and above regular processing. For example, for those of you who do write cursors, what's the very last statement you're supposed to execute in regards to a cursor? The allocate, right? Cursors take more resources than a regular select statement. And so you should technically give those back when you're done processing it, right? It takes additional locks, additional space and memory, and so forth. But one of the weird things about SQL Server is that it is way over in the default. For a lot of things, SQL Server, the dev team said, we're gonna fulfill the minimal requirements of the standard as the default behavior, and then you can add a switch or you can add some statement or something like that to make it do everything possible. Well, in the case of cursors, they did it the exact opposite of that. They said, we're going to give you the most rigid, least flexible, least high performance version of cursors as the default, and you're going to be happy with that, right? So let's say, for example, does anybody need to run now? Okay. Yes. So to get the slides, go to slideshare.net and look for user Kline84. Or you can go to my website, kevinekline.com. Mm-hmm. Right. Right. Let me finish this trick, and then we'll take a break. Anybody needs to leave can do that. So a typical way to do a cursor. So I'm gonna just execute this block here. I've declared my cursor. I'm calling it C1. It's just a sys, join between a couple items in sys objects, and we print out some values and that sort of thing. Let's see how long it takes to process here. I think it's 15 seconds or so. Very typical behavior in the cursor. All we want to do is go forward record by record through our result set and look at the value. Okay, that's all we want to do. So by default, SQL Server, so it took 16 seconds. But a lot of people don't realize that by default in SQL Server, or down in a result set. And you can also say, you know what, I don't want you to go one record at a time. I want you to go 5 records at a time. So go up. You could say, instead of forward, you could say back or backward, BS, absolute. If you go backwards, it's results in records at a time. Ever actually do that? Very seldom. So one of the other defaults of the server is the read-write access to read records, right? So it concerns the writability of the cursors. And then finally, we can just local in regards to the context of the cursors and whether I can, pick up other places in it, and for my particular connection, whether I can access it again. So let's do the same thing, except now we're going to turn those defaults off. So we're going to say, no, I don't want logic. I just want to read. That's what the fast forward says. So 16 seconds before, and I didn't tell you I came in, so I'm not sure how much better it's going to do. Oh, so, right? That's pretty good. That's pretty good. Twice as fast. So, difference. Why would I use a cursor versus interesting thing? Equal performance virtual up there that shows that they're virtually the way they perform. Yep. A few more locks. But they're pretty much the same thing. All right. So we're going to go ahead and pause at this point. And let's take a few minutes. Anybody who needs to leave, you can do that now. Did you want to do some raffling or some giveaways or something like that? Okay. How are you going to do it with your registration? Okay. Well, let's do this. I will cheat. Let's see. Who's number 33 on that list? Yeah, he's like, oh, look at that. It's Dave Packler. Oh, what a coincidence that. John. All right, John. Does he have his username? Or, you have an email address on there? Okay. Okay, excellent. So what, your grand prize winner, congratulations, John, $300 product. Let's choose one more. Choose one more. Let's take, I don't want to make you count very high. What's number 13? Lucas. Lucas, you were the winner of the courier bag. So we'll follow up with both of you with an email afterwards. We'll get your mailing address and stuff so we can ship that out to you. And I need you guys to get a picture, So you want to? Are you able to stick around for a little bit, or do you need to leave soon? You okay, Lucas? Okay. All right. All right. What else do you need to do? You have some other giveaways of your own? Oh, we see. You have for pro built into performance elastic. Um, Up to date with your releases and stuff like that.
It is slow.
Well, and you can get that all developers.
Kevin, for those that are
We'll go quickly. One thing I do want to ask, if you've got a T-shirt, can we get a picture of everybody with a T-shirt? Or let's give out. I think everybody's gotten one is left, right? Let's give out the rest of those then. See if we can. My boss wants me to get this stuff going on social media, so we got extra larges. Woo! We did have a couple meetings, but they might all be gone already. There you go. What do you got left? Woo! Uh-oh.
large,
Large. I need one of those cannons, right? The T-shirt cannon. You can wear a large. Anyone? They're a little bit big. I wear a large. So.
take it back to the office.
All right, before you go, let's get a picture, okay? Oh, all right. Oh, you want to do it now? You want to take a picture? All right. So how about this? If you've got let's gather up here. If you've got a T-shirt, just drape it over yourself like Dave was doing there, and stay in the front row for me. So, hey, look at that. Oh, that's fine. I understand. Yeah, what a good-looking crowd. All right, smiles. Okay, one more. That looks great, folks. Thank you. That's awesome. Now, here's what I'm actually going for. If it goes off really well, let me do this again next year. That's what I want. All right, we don't have a lot of time left, so I'm going to just give you two of the last five. We're going to go through these pretty quickly. One thing that I've found, in particular with people who are new to SQL Server, or maybe they're new to relational databases, is they don't know one of the cardinal rules about indexes, which is, well, indexes are awesome because they make your queries and all kinds of different transactions a lot faster. But anytime you let's say you've got a SQL statement that selects from a table, and you have a where clause that hits one of the columns that you have a non-clustered index on. What they don't realize is that when you put a function on that column, it can't use the index anymore. Okay? It breaks the availability of that because SQL Server says, okay, there's an index on there, but this function, unless it's a deterministic function, if it's non-deterministic, meaning I don't know exactly what the result set might be like at any given moment, I can't count on that index being of any value, so I'm not going to use it at all. Now, that's dangerous in and of itself because people will make all kinds of function calls on a column that's indexed and never realize that they're not getting to use that index. That's dangerous. But what's even worse is when it happens with no explanation. And that is where implicit converts come in. So what happens very, very frequently, and this is really bad with if you're using ORMs. ORMs are terrible about this. So what can happen inside a SQL server is an ORM will declare anything that's like Entity Framework or in Hibernate or those kinds of things. The old Link to SQL was better at this. But what it will do is it'll use in varchar for varchars, and it'll use in varchar for chars. So it'll use in for those. The thing is, in varchar is Unicode. Varchar, not Unicode. Not at all the same data type. They both have varchar in there. They look like they should, but SQL Server says these are incompatible data types. And so therefore, behind the scenes, what I need to do is actually issue my own private little case statement to make it work properly. And so you can see this in all kinds of situations. In this case, I've created a couple of quick tables, and it could be in the from clause, right? It doesn't even have to be in the where clause or in the join clause. So here is implicit conversions in the where. A little bit earlier, we've got implicit conversions here in the due to the join, because category ID in one is an integer, and here's category ID as an integer, and in the other, category ID is a varchar. Same thing as if it was in varchar. Another very common set of data type mismatches that we see is if you have float or money or numeric or decimal, and then you have integer. Integer is not compatible with those. Small int or any of those kind of things. So when we execute these, whoops, I'll just do all of these. Oh, it's already been declared. So if I just execute these, how about I just start over? You'll see very different execution plan. Oh, darn it. There's a redeclaration in here. Oh, yeah, each time. Sorry about that, guys.
I promise I pay attention.
No. Each time it produces different execution plans. And it also, so it produces different execution plans because in one case it can use an index, in another case it can't, right? And it will also take a lot longer. There'll be a lot more work to do, and hijinks ensue. Right? Now, there's a couple utilities that are in the slide deck notes that you'll want to make sure that you get a chance to play with. The first is from Jonathan Cahias, one of my favorite bloggers. And so he's written a script. It's kind of, it takes a while to run because it goes through the entire plan cache. But what it does is it looks for appearances of the convert implicit operation. Okay? So it says, so let's say you don't know whether you have this happening a lot in your workplace. You can use this script, take it back to, well, you know, if you're going to do it in production, maybe come in a little bit early before everybody's busy, or stay a little bit late after folks head home and run it when there aren't a lot of people on there, because it is a little bit heavy. But it will tell you all of the different stored procedures and so forth, SQL statements of different kinds that are executing that have a implicit conversion occurring in them. So if you haven't rebooted your server in a long time, that means, and you haven't cleared the cache in a long time, you get a really good picture of what statements are doing this. And I hope, for your sake, that there aren't a lot, right? Because it's not good news when this happens. There's also another nice little piece of code in there. There's an author and blogger named Ian Stirk. He's a British guy. He's got a book out by Manning Press about DMVs. And one of the books one of the utilities in there he has does a quick look at all of the functions and views and tables, and it looks at all the data types in those. And if it sees, let's say, quantity, or let's say maybe an ID like stock ID, and if they're same thing as in two tables and they're different, it tells you. Now, a lot of them, like in this case, we've got human resources, start date, and some of them are date and some of them are date time. Those are all in the date family, so those will execute without an implicit convert. But so it doesn't actually rule out all of those. But varchars of very different, or in varchar of very different size. If you ever have like an in varchar max, it will do an implicit convert if you have it going against an in varchar 10, because they're so different in the way SQL Server handles the max, even of the same data type. It will show up on your list here, and then you will have some, hopefully not too many, but you'll have a few that you will find that will be. I think we had some closer to the end in here. So we've got some that are integer and decimal, for example. Those are not compatible data types. Money and numeric, I think those are. So this will look at your existing code, your existing schema, and let you know you have a possibility for implicit conversion. Yes, question? Well, it depends. It depends. So if you're like if you cast and it's in your where clause and it's comparing to a parameter, that might be the case. I've seen it happen a lot where a programmer wrote the parameters, declare statements up here, and it wasn't the same data type that what it was being cast to. But I'm not sure I'm actually really understanding your question. Yes. Yes, that's correct. And that is in the slide notes. If you pull down the slide deck and look in the notes, there's a link in there where you can pull down a very nice PDF poster of the slide hierarchy and conversion. I guess there's a conversion hierarchy. Integer can convert to these types successfully, and other types with the conversion to that. Yeah, I think it's just in the code that's in the metadata. So if it's not in the metadata, it won't catch it. It will catch it in the execution. The first part, Jonathan Kaisis, that will catch it. Yes. Of course, it has to have been executed and put into the cache, but it will find it if it has occurred. Yes. And so that is correct. And so what a lot of people do is they find a way to put it onto the other side of the equation. So you convert the input value rather than, like if you have a where, and where this column equals such and such, you change the such and such, not the column. Right? If the column is in varchar 40 and you're comparing it to something that's not in varchar 40, that's what you would cast rather than the column. Does that make sense? All right, let's do one last one real quick. There's a few more you might want to look at in the slide deck, things about the different value of temp tables versus temp variables and some of those kind of structures. There's also some recommendations around knowing your workload, particularly around indexing, because a lot of people tend to think, oh, here's a column that I use a lot to find records. I should put an index on it. Or the database tuning wizard has given me some index suggestions. I should go ahead and create them. The problem is indexes only help speed up select statements typically, right? So if you have a very heavy workload for write operations, inserts, updates, and deletes, having lots and lots of indexes may not be helping you. It may even slow you down because every time you make a change in a record, you've got to update all the pointers and all the indexes. A friend of mine tells a funny story about how he was doing some consulting for a major sports franchise, and they had a database that had like 40 tables in it, and you know the tables averaged a dozen columns, and one of them had like 170 indexes in it. He said, "What's your strategy?" He was trying to be diplomatic. "What's your strategy around indexing?" And the DBA said, "Well, we go to dev, we run the select statements that are slow through the database tuning advisor and find out what indexes we need to add, and then we add them in production. And at what point do you add those in development where you're creating?" So they were getting advice from a server that never had the indexes applied. So in fact, they had 30 and 40 indexes of different names on the same column, same index, same column. So every time you make an insert, it had to update 30 and 40 pointers to each column on a given table. So he just came back and rewrote the indexing scripts, and it was like, "It's incredible! You're the best consultant we've ever worked with." It's like, "Thank you. I know. Thank you very much." All right. Now, one other thing I want to point out too is that SQL Server is just so darn tricky about code. So this is one of the reasons why I'm a huge proponent of being rigid, being not very flexible about your coding standards among your team. Okay. Being rigid and inflexible yourself, like don't do it different ways tomorrow versus today. Like today I'm energetic, I'm going to put all the keywords in uppercase, and tomorrow I'm kind of tired, just sloppy, just everything's lowercase everywhere. The reason for that, let's say for example, I'm going to clear out my caches. I've got a couple queries here, identical query. The only difference between these two queries is that one has a line break, okay? Now, they're identical queries. Identical, except for line break. How many do you think we're going to find in the plan cache now? There are 2 in the plan cache. All right? Now, what if I don't know, I just have 1 extra space in here? How many do you think I'm going to find in the plan cache now? 3. Yeah. What if I have my entities are, instead of camel case, they're all lowercase? Right? Or maybe I just do everything in lowercase. So notice the size and bias. Every time I do it a little differently than you do it, this is what our plan cache is going to look like. Bloat, right? And then remember how SQL Server can choose to reuse plans? Which one of these do I choose to reuse? I've got to look through 5 times as many to figure out which one is most reusable in a given situation, right? So we spin cycles on it. So that's one of the reasons why I always uppercase keywords, lowercase object names, identifiers, and stuff. So I just do that because that way I avoid this plan cache bloat. And that's another thing that we see happening all over the place, particularly in big teams, that they don't enforce any coding standards. The most beautiful code I ever saw was when I was doing some work with BMW. Those guys are serious about, about their craftsmanship. I also worked with a Swiss watch company once. That stuff looked like clockwork inside of their database engine. Really, really beautifully done. Does make a difference in performance. Is this going to make like a 20% change in your performance? I don't know. Your mileage may vary, but it will make a few percentage points, maybe low double digits, depending on how much of a mess you've got inside of your SQL server in your code there. All right. So I don't have time to show you all the other tips and so forth, but please do download the slide decks just to give you a quick preview. Talked about optimizing for select versus the DML operations, inserting an update. Talked about temporary structures, and so we were just a little bit behind on getting all these details. Also, just to finish up, please do send me email at Kline@SQLcentury.com. If you have any questions, if there's anything I can do to help you with, I'm on Facebook, LinkedIn, and Twitter, all of those at KE Kline. I try to go by Kevin in my middle initial, E Kline. Still get about 2 fan letters a month for the actor by the name of Kevin Kline. I just got one from somebody who worked with him on a film in the 80s. But that was the lighting person. This is such, can you loan me money? The slides are on my website as well as on SlideShare. I would appreciate any kind of social media love you could provide. So if you like it, please put a thumbs up on it on SlideShare. You know, if you were on Facebook or Twitter, say, I read this and I thought it was good, or I thought it sucked. And then also, as I mentioned, I've got paraphernalia for you if you're interested in learning more about what we do at the 4IT Pros Consulting stuff. And we got some cute little stickers too if you want some stickers. So, folks, thanks so much for your time. Appreciate it very much. Yes, sir.
Thank you, everybody, for hanging on a little bit longer than normal. I appreciate that. We will see everybody next month. We'll be back on our Thursday schedule, unless Joanne and I run into scheduling issues. But we'll let everybody know.
Yeah, grab anything you can get there.